Hello, in your company you're working with Kubernetes and you'd like to reduce your bills by a factor of 2, 3 or even 10. Maybe SlimFaas is for you. And in this video, I'm going to show you what SlimFaas is all about. In several parts, first of all its features, then its architecture, and then how to configure it with a small demo, so 4 short parts. Let's get started. So, what features does SlimFaas offer? First of all, SlimFaas lets you turn off your pods after a period of inactivity. This is handy if you're provisioning your virtual machines that host your pods. If your pods are shut down, you can deprovision them, freeing up servers and saving you money. SlimFaas supports both synchronous and asynchronous HTTP calls. I'll go into more detail on how this works. In asynchronous mode, SlimFaas's built-in queue system will protect your underlying pods from load peaks. SlimFaas incorporates a retry pattern with a 2, 4, and 8-second scale in the event of a 500 HTTP error. SlimFaas also integrates what I call a mind changer, i.e., it offers a REST API. What's happening is that in your companies, perhaps you have pods that are a little too big, a little too bulky, that can take quite a long time to get started. You may have internal applications that don't have too many users during the day and that stay on all the time. With SlimFaas, you can, on the UX side, make a change of mindset and find out the state of the underlying infrastructure, allowing you to display a message that the infrastructure is switched off. With this REST HTTP interface, you can also start the infrastructure, allowing you to say infrastructure startup in progress. As soon as it starts, you'll know. You can let the user browse his application normally. It's a mind changer. SlimFaas and plug and play, that's really important, i.e., in your architecture, SlimFaas won't couple you at all. You take SlimFaas, it's a stateful set pod, you install it, you put one minimal annotation in your existing pods, and voila, it's functional. It can work with SlimFaas. And very importantly, SlimFaas is very light and very fast, and as time goes on, the lighter and faster it will be. So now I'm going to focus on the architecture. How does it work? SlimFaas acts as an HTTP proxy, meaning that all HTTP requests have to go through SlimFaas. How does it work? You call the SlimFaas URL for a synchronous call, add function and then pod name. If you add paths, for example, /hello/Guillaume, as in the demo here, then this hello/Guillaume. In HTTP, get here will be transferred to the path of the underlying pod being called. Note that all HTTP verbs are supported, so you can put any path you like behind it, and it will be transferred to the underlying pod. For example, if you send an HTTP post to the Fibonacci pod to perform a Fibonacci calculation, SlimFaas will receive the message. Note that the SlimFaas pod integrates SlimFaas plus SlimData, an integrated Redis-like database. I'll explain how this works in more detail later. The pod has received the message and needs to be redirected to the Fibonacci pod. Imagine that there are no Fibonacci pods running. SlimFaas will launch the startup. It will wait until the pod is in Redis-like state before it can start making the request. It will make the request, and imagine there's an error, and then the retry pattern comes into play. And if all goes well, SlimFaas will return the result to the user in synchronous mode. That's for synchronous mode, but you may also have real-time streaming architectures, a bit like we have in our projects, especially in AI. What's interesting is that you can set up an asynchronous architecture. So what do? You call SlimFaas, and instead of function, you put async function, knowing the name of the pod. In the same way, all the passes we add will be transmitted to the underlying pod. So SlimFaas will receive the request and immediately put it in a queue specific to this Fibonacci pod. There's no configuration to be done. It's all going to take care of itself. What will SlimFaas do next? It'll listen to the queue, and if these pods are available, and in the SlimFaas configuration, for example, you can say, I only want a maximum of 2 parallel calls. For a pod, imagine that there are 4 messages in the queue. SlimFaas will take 2 messages only and call this pod with a classic HTTP call. Once the HTTP call has been completed, SlimFaas will have the answer and will then be able to unroll a new message so that there are only 2 parallel calls each time. Why is this? Because it will protect your infrastructure, i.e., imagine you receive 1,000 messages at once and there's only one pod available. SlimFaas will start taking 2 messages and calling that pod, which will allow the infrastructure to start scaling, i.e. to put in another pod, and SlimFaas will know that there are 2 pods. So instead of sending 2 messages, it will send 4. And if there's a third pod starting up, instead of sending 4 messages in parallel, it will send 6, enabling messages to be unpacked much more quickly. So this will protect the infrastructure and let it scale as quickly as possible, but at its own pace, without syncing it so that it can continue to unload messages in the event of a load peak. Practical for asynchronous architecture, and it's working extremely well in production today. Synchronous calls. 2 other features are also available. There's a status functions route after the pod name, which lets you know whether or not the pod is switched off and whether or not you've asked for it to be switched on. And there's also a function that lets you say, I'm waking up the function, i.e. I want to start the infrastructure. So these 2 routes are very useful for using this in a web interface and knowing the status of the infrastructure and telling the user it's off, I'm triggering the startup, it's starting up. And the front end will know when it started and can make the interface available to the user. We can start with a short demo. To get started, you can test SlimFaas demo with just a few lines of code. Just copy these lines and paste them into a terminal. What I'm going to do is that I've already cloned the repository, so I'm just going to start a new Kubernetes namespace, which is going to take a little while because I've got the video running and recording the video takes up all my PC's resources. I forgot to show you. You'll need here Docker Desktop installed on your machine and with the Kubernetes plugin. There you can see that the startup is in progress. It has started SlimFaas and the Fibonacci pods, and SlimFaas has started and shut down the Fibonacci pods. We installed 3 Fibonacci pods for demonstration purposes. To create all this, I'm going to explain a little about configuration before doing a demo. In terms of configuration, we had to install SlimFaas. The SlimFaas pod, I'll go into more detail later, needs to know how to call pods internally in namespace. It's part of namespace, and we've got a classic pod with classic pod syntax, and we've just added an annotation to it saying SlimFaas function true. This is the only mandatory annotation for any pod as a function. Next, we've specified the minimum number of replicas, i.e. after a certain period of inactivity, we'll set the number of replicas to 0, we'll shut down. At startup, we start only at 1 pod. This is an interesting property. Replicas start as soon as one function retrieves a request. Here, false. But if you set this to true, as soon as SlimFaas receives a request to a pod, even if it's not for us, that pod will start, thus warming up the infrastructure. Timeout second before setting replica min. This is 300 seconds. This means that after 5 minutes of inactivity, this pod will be shut down. Here, we've set the number of parallel requests accepted by a pod to 10. This is for our asynchronous architecture. We'll limit the number of messages we send to this pod to 10. If there are 2 pods, SlimFaas will send a total of 20 messages. For the demo, we have 3 Fibonacci pods, 1, 2, 3. Here we didn't take 300 seconds, we took 10. For the Fibonacci 2 pod, we set this property to true so that it starts as soon as we receive a request. I've created a little web interface for the demo. Here, if you click on this button, it will send an HTTP post to a Fibonacci calculation of 10. Here's a little route that wakes up the infrastructure. Here's a timer to see how long it takes for the demo. Here, every second, we pull SlimFaas to see if the Fibonacci 1 pod has started. It hasn't started yet. You can also see here that my container hasn't started. You can see the status of the request to my Fibonacci call. The result will appear. Here we go. I'm going to reset the timer. I'll make a call to my Fibonacci pod. What's happening now is that my environment is starting up. My pod 2, since it had the property that it was going to be preheated, is also starting up. Pod 3, on the other hand, was never called, so it won't start. You can also see here that I have 2 Fibonacci pods that have started. Here, my Fibonacci calculation is in progress. This is the first call. I deliberately took a pod that wasn't extremely fast to work with. It's a bit long. I think it didn't work because of the video that's running. The video that's running, I think it crashed. We'll try again. I think my Fibonacci 1 pod crashed because of the demo. I'll do a wake up so it doesn't shut down. My Fibonacci normally is quick to calculate, but with the video recording, I think it overloads my infrastructure. This took a long time. The pod had to start. Doing the Fibonacci took 28 seconds. As long as it's running, you can see that my Fibonacci function is extremely fast. The result is 55. Here, I have my pod 2 already started. It's actually pretty quick to execute. Now, I'll make a request and we'll wait 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And normally my pod will shut down. That's the demo only. If I'm in a front-end interface, I could detect that it's not started before displaying my user interface. Instead of waiting 30 seconds for the first call, I can use this wake up route to say that I'm waking up my infrastructure. Instead of taking 30 seconds for the first call, i.e. the startup time, etc., I can use this wake up route to say that I'm waking up my infrastructure. Depending on your company's configuration, this may start up a virtual machine. Then it's ready. As a result, I'll be able to do the Fibonacci job. In fact, it'll take less than 30 seconds. It'll take a long time because it's the first call, but it'll take less than 30 seconds. 11 seconds is more acceptable than 30 seconds, which may exceed the timeout of your HTTP routers. That's all for the demo. The environment shuts down after 10 seconds. I'll finish by telling you a little about the Slim data part. What happens is that the SlimFaas pod is a stateful set pod. In other words, it integrates a real database. In other words, it's a fully integrated ready-like. In other words, if you have several SlimFaas instances, and it's advisable to have 3 in production for high availability, the SlimFaases will communicate with each other. The SlimFaces will communicate with each other to synchronize status. What happens is that it works with the Raft protocol. In other words, there will be a master node, and the other 2 nodes will be slaves. The slaves will synchronize the data with the master. All writes will take place on the master node. That's why internally SlimFaas opens a second HTTP port, which you mustn't expose to the public but keep internal. All writes are made via an HTTP call to the master node. Reading is extremely fast because it's done directly on the master or slave node. What else can I say? What else can I tell you? The great thing about SlimFaas is that it works on Kubernetes, but you can also run it in Docker Compose. In other words, you can launch your SlimFaas in Docker Compose, which would mean you'd have virtually the same infrastructure as on Kubernetes, locally, in development, with a Docker Compose. You can launch a SlimFaas in standalone mode, not in 3, just by setting this local source property to holes. This is very useful for local development with Docker. I won't go into the details of all SlimFaas's properties, but you'll be wondering why we created SlimFaas and why we didn't use Knative or OpenFaas. Well, it's quite simple. Historically, we used OpenFaas, but OpenFaas was far too expensive for our needs. We realized that OpenFaas coupled the OpenFaas syntax to the infrastructure very strongly. The monitoring offered by OpenFaas was not adapted to our needs because we had our own monitoring with our own characteristics. Behind this, there were a lot of complex configurations to be made. For example, for the queue, we had to configure NAT in failover mode. In short, we had a lot of problems. Recently, OpenFaaS removed all these Docker Hub images, which caused us some problems. We would have liked to use Knative, but for security reasons that I don't know all the details about, I think it's because it opens a global Kafka to all namespaces. We can't have it internally in our company. That's why we set up SlimFaas. We realized that it was a little nugget because it was lightweight and easy to install. In fact, we followed what OpenFaas was doing and improved on it, i.e., by merging all the modules into one pod. That's something like OpenFaas doesn't offer. And behind that is built in .NET, which means we'll be able to benefit from .NET updates as they come along. It's important to know that today it's not yet as fast or as light as it should be because I haven't yet succeeded in compiling it in native mode because there's a dependent library that isn't yet adapted, but that's going to happen in a few months. And finally, what's next for SlimFaas? What features are we going to add? We need to change the scale down configuration or even set automatic startup at certain times of the day. So for example, at night, we could scale down after 5 seconds, but during the day, we'd scale down after 10 seconds or an hour. And for example, in the morning, you could say, when we start the 1 hour scale down, we activate the automatic startup, just one startup. What's the point? It's going to come in handy in certain cases where pods take a long time to start up, and we want to avoid this initial startup time for the first user of the day. Today we don't scale down stateful set pods, but we need to do so in certain cases. We're going to turn off the databases outright, but it will also be practical in development environments to say that the databases are turned off at night. What's more, we won't lose the data as the databases were stateful set and will end up today. For scale up, we use HPA. In other words, SlimFaas is HPA compatible, but tomorrow the idea is to manage scale up directly via SlimFaas. Why is that? Because SlimFaas will have all the data on the underlying pods, the response time, the number of messages in parallel, and this will really enable SlimFaas to use this data to fine-tune how we scale up the underlying infrastructure. Better than an RPA, and I hope better than a Kida tomorrow. And that's it. That's all for today. Thank you and see you soon.